the notes for section 3.1 on extrema. So the three things we're going to get accomplished today: understand the definition of extrema of a function on an interval, understand the definition of relative extrema, and find extrema on a closed interval. This is our homework from our textbook. Let's start with the definition of extrema. Extrema has the word extreme in it. So these are the highest highs and the lowest lows. So we're going to have some function f, and that function has to be defined on an interval I containing c. So I is your interval, c is some x value that is in that interval. So if you have an interval from 0 to 5, c could be anything between 0 and 5. Okay. F is defined means that for every single x value, there is some y value that goes with it. So numbers 1 and 2. 1, f of c is the minimum of f on the interval. Minimum and min are the same thing. That's our abbreviation. So f of c, that y value, is the minimum if f of c, that y value, is less than or equal to every other y value for every single x on the interval. So this is the smallest, lowest y value. It's lower than every other y value, or equal to every other y value. Number 2, f of c, so the y value is a maximum on the interval if f of c, the y value, is greater than or equal to every other y value on the interval. Okay, so look at all the y values. If it's the biggest, highest one, it's a maximum. If it's the lowest, smallest one, it's a minimum. Okay. The minimum and the maximum of a function on an interval are the extreme values or extrema of the function. So if you're asked to find extrema or extreme values, look for all your mins and maxes. Okay. The minimum and maximum of a function have several other words. They are often called absolute, max or min, or absolute extrema, and global, max, min. Global means everywhere. Absolute means the very most. Okay, so absolute maximum, the absolute highest point; absolute minimum, absolute lowest point. Okay, we have a theorem. It is called the extreme value theorem. If f of x is continuous on a closed interval from a to b, so got to be a continuous function. There's no holes. There's no vertical asymptotes. There's no just empty spots anywhere. Then f has both a minimum and a maximum on the interval. So it's got to be a closed interval. There's got to be endpoints, and it's got to be continuous. Then f has a minimum and a maximum. F has to be continuous. Holes and infinity do not qualify for maxes and mins. Holes and infinity. So if the, quotes, endpoint is a hole, or if the endpoint is an arrow, it's not going to be a max or a min. All right, here we go. Let's look at some examples. I've got 3 drawn out. If you want to pause and copy, that'd be fine. Our first example, we've got an x and a y axis, and we've got a parabola piece, more or less, shown on here. So I've got a point at -2, -3, 2, 3, and 4, -3. We want to know, is there a maximum, is there a minimum, and then what are those maxes and mins? Okay. So a minimum is only a minimum if that y value is less than or equal to all other y values. -3 is the lowest y value over here. It is lower than all of these y values, and these y values, and these y values, and these y values. It equals this y value. But there's no other lower y values than -3. So this is a minimum. This is a minimum. Okay, so you can call that an absolute min, a global min, or just minimum. Okay, so the min equals -3. What about a max? A max is the very highest. So this point up here, the vertex looking thing looks like it is higher than every other y value, so it is a maximum. The max is at the y value, +3. We do not care about the x value unless it says where does that maximum occur. So if it says what is the maximum, it's the y value. If it says where is the maximum, it's the x value. All right, over here. This guy right here is a minimum. It is the lowest point. We don't really have a number, but it's definitely the lowest spot. The highest point is going to be somewhere up here. However, we know that if there is an empty circle, there's no actual point defined there. So even if that y value is like a 4, all of the points that exist on this line are getting really, 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 really close to 4, but they never quite reach it. So what if we say like 3.9 is the maximum? Can we get closer to the point? Heck yeah, we can. Get closer, 3.99. Can we get closer? Yes, 3.99, 9999. So we can get way, way, way close to that number. There's like a limit of 4, but there's no actual point there. So there's no max because of a hole. Third one. What is the lowest point? Oh, look, this continues down forever because there is an arrow, so there is no minimum. Up here, there is no maximum, same reason. The arrow is pointing up forever. So there is no max or min unless we restrict the domain. Okay, restricting the domain means that we pick an A and a B that the x values have to be between. For example, the first one, our domain is -2 to +4. This looks like it was kind of a parabola. So if this went on forever downward, if we restrict the domain to be between -2 and 4, we can find minimums there. Now, of course, this parabola would have a maximum because there's no arrow pointing up. Okay, so think about it. If there's an arrow pointing up or an arrow pointing down, there's no max or min. And if there's an endpoint that's a hole, no max or min there. All right, relative extrema. So we've talked about the absolute mins and maxes, but what about just maxes and mins within some little area, some smaller interval? So we don't have to look at the whole graph. We can just look at a piece of it. Relative maxes and relative mins can occur inside an interval. Relative maxes are the top of a hill, and relative mins are the bottom of a valley. There can be infinitely many relative maxes and relative mins on an interval, but there is only one value for the absolute max and absolute min. Let's go back to that. There's only one value for the absolute max and absolute min. Let's take a look back at this guy right here. The absolute min was -3. It's okay that there were 2 points that had the same y value that was that minimum. The value is -3, even if it happens at more than 1 point. That's okay. Same thing could happen for absolute maxes. There could definitely be more than one x value that gives you the same y value maximum. Okay. There can be infinitely many relative maxes and relative mins. So it's possible that there's a top of a hill that is very tall. There's one that's shorter. There's a shorter hill. There's another medium hill. So all of the tops of all of the different hills would be relative maxes. All of the bottoms of all of the valleys are relative mins. Okay. It is possible for a relative extrema to be equal to the absolute extrema. So if we take a look back at this guy, this is the top of a hill. So it is both the absolute maximum and a relative maximum. Okay, think about Mount Everest. Mount Everest is the tallest mountain in the whole world. There are other mountains. They are taller than everything else that is near them, but they're not taller than Mount Everest. So Mount Everest is the tallest thing in its area and the tallest thing in the whole world. So it counts as absolute max and it counts as a relative max. All the other hills are relative maxes, hills and mountains and whatever. Alrighty, let's take a look here. We have a relative maximum, boom, right there, relative max. Down here, we have a relative min. Do we have an absolute max or min? If we continue this on, we know that, graphs get cut off. That is an arrow, and down here is an arrow. If we have an arrow pointing up, there's y values that are taller than this relative maximum. I mean, here's one, here's one, here's one. So there's no absolute max. Here's a relative min, but there's other y values that are lower than this relative min. There's an arrow pointing down, so there is no absolute minimum. Okay. You are allowed to have more than one relative minimum. You are allowed to have more than one relative maximum and different spots for them. Both of these guys are relative mins. Both of these guys are relative maxes. And since there's no other spot that is taller than these, and it just continues on, this is what, sine, maybe? Sine, yep. This is also the absolute max, and this is the absolute max, right? You're allowed to have 2 points, but they have the same y value. And these are also relative and absolute mins. All right, that's the end of that page. All righty, we are looking at the definition of critical numbers now. Critical numbers is a vocab word. It's not just a silly little Miss Campbell word. So critical numbers are when f prime of c equals 0, or if f of c is not differentiable at x equals c. Okay, so c is the x value. If the derivative at that x value equals 0, or if you cannot take the derivative of f at a specific x value, then c, which is the x value, is a critical number of f.